So welcome back. So today we have next part of surface chemistry. In the last lecture we have covered difference between physical adsorption and chemical adsorption, and today we will start very important topic, that is Friendlich adsorption isotherm. Friendlich adsorption isotherm. Is it visible? Not visible? Wait. Okay. Yes, good evening all. Is it okay now? Okay, so Friendlich adsorption isotherm. First of all, what is isotherm? So isotherm means any plot at constant temperature. Any plot at constant temperature is called isotherm. Now, adsorption isotherm. Adsorption isotherm means plot of amount of gas adsorbed, or amount of, so we can write amount of adsorbate per unit mass of adsorbent means this is graph between x upon m versus and pressure at constant temperature. At constant temperature means x upon m versus pressure at constant temperature. That is called adsorption isotherm. What is x here? X is mass of adsorbate, m is mass of adsorbent, and P is pressure of the adsorbate, and that is obviously a gas. Okay, and this plot is explained by Freundlich, and that's why that is called Freundlich adsorption isotherm. According to him, at intermediate pressure, means this Freundlich adsorption isotherm is not applicable at very low pressure or at very high pressure. At intermediate pressure, x upon m is proportional to p raised to power 1 upon n, and n is greater than 1. N is greater than 1, and this plot x upon m equal to k into p raised to power 1 upon n. This is called Freundlich adsorption isotherm. This is the equation, Freundlich equation. Okay, so if we plot the graph, it is like x upon m versus p. Is it visible? Yes, x upon m versus p. It is like this. So at very low pressure, x upon m is proportional to p raised to power 1. At this pressure, intermediate pressure, x upon m is proportional to p raised to power 1 upon n, and at very high pressure, x upon m is proportional to p raised to power 0, means it is independent of pressure. At very high pressure, it is independent of pressure. So Freundlich studied the adsorption with respect to pressure at intermediate range. At intermediate range, it is like this. Okay, because p raised to power 0 means n should be infinity. That is not possible. That means Freundlich adsorption isotherm failed at high pressure. At very high pressure, it is failed. Freundlich adsorption isotherm failed at very high pressure. So this is limitation of Freundlich adsorption isotherm. This is the limitation of Freundlich adsorption isotherm, and this is the actual equation of Freundlich. Okay, that is also called Freundlich equation. Right? Any doubt in it? Yes, beta. Any doubt up to this? Now, if we take log on both sides, so log x upon m is equal to log k plus 1 upon n log of p. So if we plot the graph between log x upon m versus log p, if you plot a graph, it is again a straight line with positive slope, and its intercept is log K. Log K is intercept and slope is 1 upon n. That means from the slope we can calculate n. And n and k both depends on n and k both depends on nature of adsorbate and adsorbent as well as temperature. N and K both depends on nature of adsorbate and adsorbent as well as on temperature. So this is all about Freundlich adsorption isotherm. Okay? Next is application of adsorption. Application of adsorption. First is to create ultra vacuum. Or we can write in preserving vacuum. Like if we attach a vacuum pump to remove gas or vapors from the container, and after that there are traces of gases inside, traces of gases. In order to remove those traces of gases, we add adsorbent so that those gases are adsorbed on its surface and therefore there is an ultra vacuum. Got it? What we do? First, this is the container, we want to have a vacuum in it. Okay. So what we do? First we attach a vacuum pump. Now when vacuum pump is attached, all the gases are removed, but traces of vapors or moisture or gases are remain behind, and therefore if we have some kind of adsorbent, then that adsorbent will adsorb those gases and therefore whole container is free of gas, free of vapors or gas. So in preserving vacuum we can use this technique, the adsorption. This is the application of adsorption. Okay. Now in gas mask, in coal mines, there are poisonous gases like carbon monoxide. So on now mask, everyone knows, but there are special kind of mask which adsorb the gases. not absorb. What? They absorb the poisonous gases. They absorb the poisonous gases. Okay, and that's why that is also an application of adsorption. Okay, third one is in decolorization of sugar. In sugar there is a brown or we can say a brownish or yellowish material inside. Clear? To remove that colored material, to get that white type of sugar, what we do? We pass that solution into an adsorbent, that is animal charcoal. We pass that through we make the solution, okay, and that solution is passed through animal charcoal. Animal charcoal absorb that colored substance, dye, and therefore we get the sugar solution without or free of color. Right? Now, in chromatographic analysis, what we do, like column chromatography. So this is the column. Of this, in column, there is this is just like column is just like a burette, but its size is bigger than that. Okay, so we add adsorbent in it. This is adsorbent. Now let us take, we have 3 component solution. Means chromatography technique is used to separate the components or to purify the component. Right? Now when we add these components which have different adsorbing power, So, let us take A is least adsorbed and C is most adsorbed. So one which is most adsorbed is at the top, and one which is least adsorbed, that is at the bottom, and midway is the other one. Okay, so first of all A comes out. This process is called, this process of removal of the components or separation of components, that is called elution. So first of all A component comes out, and then B component, and at the end C component. So this is also an application of adsorption. Right? Now in heterogeneous catalysis, like when we deal with gaseous components, I will give you one example. Like we have this hydrogenation or reduction of ethene. So what we do? We use platinum or palladium or nickel. So hydrogen is gas, ethene is also gas. So gases these gases first adsorb on the surface of this metal. Okay, and what do you mean by heterogeneous catalysis? When reactant and catalyst are in different phases. They are in different phases, like these are gases and catalyst is solid. So solid provide the surface. So these gases first adsorb on its surface and then further reaction takes place. Okay, so in heterogeneous catalysis, adsorption is one of the main thing, main principle. Okay. Oh, thank you. बेटा GOC करेंगे हम afterwards. After this chapter, surface chemistry, then we will start organic. Okay. In adsorption indicator. So in adsorption indicator, most of the components, they adsorb dyes. So some of the adsorption it can be used as an adsorption indicator. Okay, so that is also an application of adsorption. Even in separation of inert gases. So keep in mind, adsorption of gases is directly proportional to ease of liquefaction. Ease of liquefaction. Now, out of helium, neon, argon, krypton and xenon, tell me which one is easily liquefied? Yes, question for you. Which one is easily liquefied? Wrong answer. Yes, beta. Anyone else? Which one is easily liquefied? These are inert gases, so out of these you have to choose. Yes, it is xenon. It is xenon. Why? Say ease of liquefaction is proportional to intermolecular attractions. It is proportional to molar mass. It is proportional to number of electrons. Okay, so number of electrons and also it proportional to size. So size of xenon is largest, number of electrons in xenon are maximum, molar mass of xenon is more, and intermolecular attractions of xenon are maximum. That's why this is the order of ease of liquefaction. That's why if high pressure is applied, Let us say this is the container containing all the inert gases. Now we apply high pressure. We apply high pressure. So, and there is an adsorbent. Now all the gases get absorbed. Now we release the pressure. So if we release the pressure, which gas comes first? Obviously, which is least adsorbed. Which gas comes out? Which is least adsorbed. Got it? So that means helium comes out first, and then neon, then argon, then krypton, and at the end xenon. In this way we can separate them. Got it? What we do? We add adsorbent here and mixture of inert gas. Now mixture of inert gas is inside and we apply pressure. As we apply pressure, all the gases get absorbed. We can decrease the temperature as well. Decrease in temperature and increase in pressure, both will increase the amount of adsorption. So what we try to absorb all the gases, whole mixture. So to absorb whole mixture, we apply pressure and we decrease the temperature. So all the gases get absorbed, then slowly we release the pressure and increase the temperature. So first gas which comes out is the helium. After that neon, then argon, then krypton, and at the end xenon. That's it. Okay? Even in curing diseases, there are few medicines which can act as adsorbent. What they do, they absorb the poisonous substances, bacteria, virus, okay, which are harmful to us. Their purpose is only to get out those things from our body. Okay, so they act as adsorbent. Okay, means what it means, some drugs can absorb germs on them. And hence kill them. And save us from diseases. So adsorption is very, very important phenomenon. Oh, thank you so much, Faisal Ahmed Khan. Welcome, beta. Even in dye industry, dyeing means coloring or means giving some other texture to the fabric. So dyes are used and they also used as an adsorbent. Okay. As a dehumidizer in removing moisture from air in the storage of delicate instruments. So tell me the name of any dehumidizer or any dehumidizer which is available in excess, which is used everywhere. Dehumidizer. Yes, beta. Question for you. Very good. Silica gel. It is available in excess and everywhere, even in water bottle. Simple. You know, there is a pouch of those glassy particles, small balls. So what is that? That is a silica gel. So silica gel is used as a dehumidizer to remove moisture from the air or to store delicate instruments which are harmed by the moisture, because there is a chances of deterioration of the substance by corrosion or by corrosion, like iron, rusting of iron. Okay, so corrosion is because of humidity. Okay, if the humid atmosphere is there, corrosion takes place. Clear? So in removing moisture from air, in the storage of delicate instrument, we use dehumidizer, and that absorb moisture from the air. Okay, so this is all about the applications of adsorption. So in adsorption, what we did first, what is adsorption, absorption, sorption. Difference between adsorption and absorption, difference between physical adsorption and chemical adsorption, then friendly adsorption isotherm. Yes, friendly adsorption isotherm can be used in solution as well. For solution, to use same formula, instead of pressure, in that case we use concentration, and that is equal to x upon m equal to k and c raised to power 1 upon n. So this can be used for in solutions. This formula is used in case of solution. C is the concentration of the solution. Okay, and then friendly adsorption isotherm is very, very important, beta. Keep in mind. And then we did those applications of adsorption. That is also very, very important. Even yes, applications of adsorption we have done. Next topic we will start tomorrow. Okay, that is colloids. So colloidal solution we will do tomorrow. We will take daily 40 minutes class, and every day now on. Every day now on from 8 p.m. to 8:40 p.m. every day. In earlier what we did, we use Monday to Friday, Saturday, Sunday off. But now every day I reduce the time 40 minutes. Okay, and now it's every day, Monday to Sunday. Okay. Okay. So thank you. Bye bye all.